we will be starting some new stuff today, but before we do, I want to review the stuff that we've done. So first question here, we have adding and subtracting square roots, then we're going to have multiplying square roots and another multiplying square roots, and this one's actually going to kind of help us with dividing square roots later, and we'll see why when we get to it. But we'll start with the first one here. If I want to simplify the square root of 45 minus the square root of 500, what do I need to do first? We're going to do factor trees, right? So keep in mind that when we do this, when we are adding and subtracting, we have two separate terms, so we need to keep those terms separate until we have them simplified. And then once they're simplified, if they're like terms, then we're going to be able to combine them. All right, so we've got these factored here. Once I've factored them, I'm going to rewrite it. And when I rewrite it, instead of the radicands that we started with, I'm going to put the prime factorizations. Okay, again, we need to keep these separate. So all of the factors for the 45 stay in one square root. All the factors for the 500 go in the other square root. It's also really important that we don't forget about some of the factors. I see on some people's papers, if they have a factor that's like way up here and then other ones down here, you might forget about this. Don't do that. Make sure you have them all. And circling them does help with that a little bit, but you just got to go through and make sure you got them all. So I see 2 2s and 3 5s here. All right, so after I rewrite it, then what am I going to do? Circle pairs. So in that first one we have a pair of 3s. In the second one we have a pair of 2s and a pair of 5s. So we're going to rewrite again now, and when we rewrite it this time, what do we get for that first square root? 3 square root of 5. And for the second one? 10 square root of 5. Good. So those circled pairs are going to go on the outside, but they go on the outside as just one number. So remember, when we have a pair of 3s, it's just a single 3 by itself on the outside. Okay? Now, we've simplified them, so the next thing we want to do is look for like terms and combine them if we can. Can we combine any like terms here? Yeah, they're both square root of 5s, right? So since they're both square root of 5s, we can combine them. So we're just going to combine the coefficients. What's 3 minus 10? I think I heard somebody say it. What is it? -7. Good. So if we have 10 negatives and 3 positives, we've got more negatives than positives. Specifically, we've got 7 more negatives than positives. And then the radicand is going to stay the same. We don't need to worry about what order we write the terms, because when we combine the like terms, we only end up with one term, right? On number 2, we want to multiply square roots. And this isn't really the first step, at least not what we wrote down in our notes, but we will start with a factor tree. I like to start with the factor trees just to make sure I have enough room later on when I rewrite it. So after I factor them here, what's the next thing I'm going to do? Okay, we're going to rewrite it, and we're going to multiply the 3 times 2. So we're going to multiply those coefficients and get 6. And then when we're multiplying, we can put everything into one big square root. So in that square root, we're going to have all the factors for the 8 and all the factors for the 50. So we're going to have, looks like 4 2s and 2 5s. Does that sound right? Okay, now what? Yeah, now we just simplify like we normally do, right? So we start by circling pairs, pair of 2s, pair of 2s, pair of 5s, and everything's circled, so that means everything's going to be on the outside, so the square root's going to be gone. So we will not have a square root in our answer. And so on the outside, we get 6 times 2 times 2 times 5, which is 120. And again, no square root because everything was circled, so everything ends up on the outside. Last one. we have the square root of 24 times the square root of 24. This is a multiplication problem also, right? Now, I'm going to do this problem two ways. The second way is going to be kind of a shortcut, but let's do it the way we have been for now. We don't have any coefficients to multiply together, so we'll go ahead and start by doing factor trees. We got 4 times 6, 2 times 2, 2 times 3. You could have done that maybe a different way, but in the end you should get 3 2s and 1 3. And then for the other 24, you're going to get the exact same thing, right? So when we rewrite it, how many 2's do we have?
6.
All right, 1, 2, 3, 4, 5, 6, and then 2 3's, right? Okay. Then we circle our pairs. Pair of 2's, pair of 2's, pair of 2's, and pair of 3's. Again, everything's on the outside. So on the outside, we get 2 times 2 times 2 times 3, which is 24. Okay, we actually know that because if you look at your factor tree, we have 2, just looking at one of the factor trees, 2 times 2 times 2 times 3 is 24, and that's what we started with. So if you think about what's happening here, every factor in this 24 can pair up with a factor in this 24 because they're all the same factors, and so you end up with the same number that we started with. The only difference is this 24 is on the outside, and these 24s were on the inside. So if I want to do this a slightly different way, this is the same thing as the square root of 24 times 24, right? You guys agree with that? So we're just, or a better way to write it for our purposes would be the square root of 24 squared. Because then we can do what? We can cancel the square and the square root out and we just get 24. Okay, or I could even do that over here. If I look at this here, even though 24 isn't a prime number, it's still a pair of factors. So we could circle that pair, and that pair of 24s would go on the outside, and we would get 24. So there's a few different ways we can think about it. But what's really important here is if we take any square root times the same thing, the same square root, then what are we going to get? We're going to get that number, but outside of the square root, right? So just to give you another example, just a simple one here. What's the square root of 7 times the square root of 7? 7. So if we take any square root times the same square root, we're going to get the radicand, but it's going to be on the outside. All right, and that's going to be really important for us when we're dividing square roots, because we're going to need that to help us simplify some of them.